the universe appears silent, a vast cathedral of darkness, where galaxies drift like lanterns across an endless ocean. To the eye, there is no sound, no rhythm, only the stillness of eternity. Yet silence is an illusion. Beneath the quiet, the cosmos beats with a hidden pulse. It is a rhythm written into space-time itself, a whisper from the beginning, still echoing across billions of years. The faint shimmer of ancient light, stretched thin by time, carries the memory of primordial sound waves. Pulsars, corpses of long-dead stars, sweep their beams across infinity like cosmic metronomes, keeping time with a precision beyond any human invention. The very fabric of the universe vibrates, its vastness sculpted by ripples, oscillations, and waves. This pulse is neither heard nor seen, but felt, a hidden order in what seems like chaos. Galaxies gather along invisible filaments, tracing the memory of sound from the universe's first moments. Gravitational waves tremble through the void, announcing collisions in distant darkness. To the untrained eye, the cosmos drifts without direction, but to science it marches to a rhythm older than stars themselves. And yet, a question lingers like a shadow. If the universe has a pulse, what is it beating for? Is it the echo of creation, a fading note from the first explosion of light? Or does it hint at a deeper music, a rhythm that not only remembers the past, but guides the future? The opening closes with a haunting thought. The universe may not be silent after all. It may be alive with rhythm, a cosmic heartbeat, a pulse that guides the cosmos. The story of the cosmic pulse does not begin with telescopes, satellites, or detectors listening for gravitational waves. It begins with human eyes, lifted to the night sky thousands of years ago, long before equations, before physics as we know it. There was intuition. Ancient people, gazing upward, noticed something profound. The heavens moved with rhythm. The moon waxed and waned in steady phases, returning to fullness as predictably as the tides. The sun traced its path across the sky, returning each dawn with unerring precision. Planets wandered, but even their wandering obeyed hidden cycles. Eclipses arrived with terrifying regularity, as if the sky itself were counting time for civilizations. Across the earth, rhythm in the heavens became rhythm in life. The Mayans built calendars of astonishing precision, binding agriculture and ritual to celestial cycles. In India, cosmic cycles were envisioned as vast ages of creation and destruction, each universe pulsing into being, then dissolving again, like breaths of eternity. The Greeks imagined celestial harmony, planets as spheres that sang inaudibly, their distances corresponding to musical intervals. They called it the music of the spheres. These were myths, philosophies, intuitions, but at their heart lay a recognition. The universe is not chaos. It moves with cadence, with order. A pulse was already suspected, though its nature was unknown. Then came Johannes Kepler in the 17th century. A man of mathematics and mysticism, he inherited the careful data of Tycho Brahe, whose nightly recordings of Mars spanned decades. From that sea of numbers, Kepler extracted laws. Planets move in ellipses, not circles. They sweep equal areas in equal times. Their periods relate to their distances in harmony. To Kepler, this was not mere mechanics. It was geometry turned into song. The solar system itself, he believed, played music, inaudible but real. A cosmic symphony. Isaac Newton followed, and with him the mystery deepened. Newton's laws of motion and gravity showed that celestial music was not imposed by divine harmony, but born of universal law, the same force that pulled an apple too. Earth kept the moon in orbit. The rhythm of the cosmos was written into gravity itself. Orbits became the first scientifically defined pulses of the universe, precise and predictable. But Newton's vision was static in one sense. Time flowed uniformly. Space provided a fixed stage, and matter moved upon it. There was rhythm, but not evolution. The pulse was mechanical, endless, unchanging. It would take Albert Einstein to break that illusion. In 1915, his theory of general relativity transformed the cosmos. Space and time were no longer a stage, but an active fabric, curved and stretched by energy and mass. The universe itself could expand, contract, vibrate. Time was not uniform. It bent and slowed under gravity's weight. Suddenly, the cosmos was alive, capable of motion at its deepest level. The pulse of the universe was not confined to planets and stars. It was written into space-time itself, and then a discovery that shifted everything. In 1965, Arno Penzias and Robert Wilson, working with a radio antenna in New Jersey, heard an unexpected hiss. At first they thought it was pigeons nesting in the instrument, but it was not. It was older, vaster. They had stumbled upon the cosmic microwave background, relic radiation from the birth of the universe. A whisper from 380,000 years after the Big Bang. This faint glow filled the sky, uniform yet marked with tiny fluctuations. Later studies revealed what those fluctuations were: sound waves. The infant universe was not silent. It rang like a bell, a hot plasma vibrating with pressure waves. Those oscillations froze into matter, leaving patterns that billions of years later guided the formation of galaxies. This was the first great revelation of the cosmic pulse. The rhythm of creation itself was fossilized into the very structure of the universe. Galaxies are not scattered randomly. They sit at preferred distances apart, separated by the echoes of ancient sound. Scientists gave it a name: baryon acoustic oscillations. In the darkness of space, the universe remembers its own heartbeat. Meanwhile, another rhythm emerged, discovered almost by accident. In 1967, a graduate student named Jocelyn Bell Bernal noticed strange, repeating signals in radio telescope data. They came in precise intervals, faster than any known natural phenomenon. At first, half-jokingly, the team labeled them LGM, Little Green Men, suspecting perhaps they had detected extraterrestrial signals. But soon it became clear. These pulses came from rapidly rotating neutron stars, stellar remnants, spinning with such speed that their magnetic fields sent beams of radio waves sweeping across space like lighthouses. They were named Pulsar. What shocked scientists was not only their existence, but their precision. Some pulsars keep time more reliably than atomic clocks. These dead stars had become the most faithful timekeepers in the cosmos, their pulses rippling. Across the galaxy, suddenly, humanity possessed natural beacons, guiding lights of astonishing accuracy. Scattered across the Milky Way, the discovery of pulsars revealed another layer of cosmic rhythm. The remnants of death became instruments of time. Each rotation, each flash, marked the heartbeat of collapsed suns. The cosmos was keeping time in ways no one had imagined, and still the revelations deepened. In 2015, the LIGO Observatory announced it had detected ripples in space-time itself. Two black holes had collided over 1 billion years ago, and their union had shaken the very fabric of reality. For the first time, humanity had listened not to light, but to gravity's vibrations. The universe, it turned out, could sing not only in sound and light, but in spacetime itself. Looking back, the story becomes clear. Ancient people sensed rhythm in the heavens. Kepler believed in cosmic music. Newton described its mechanics. Einstein revealed spacetime as dynamic. Penzias and Wilson heard the afterglow of primordial sound. Belbonal found pulsars ticking with perfect cadence. LIGO revealed space-time trembling. Every step has peeled back the illusion of silence, revealing a universe alive with rhythm. The cosmic pulse is not metaphor, it is physics. It is history written in vibration, order carved into the void, and yet the discovery is not complete. Each revelation leads to deeper questions. Why do these rhythms align so perfectly with the growth of galaxies? Why do pulsars remain so precise? Why do the ripples of the early universe echo across billions of years with such clarity? The cosmos is vast, yet it carries memory. The pulse that guides it is not only an echo of its birth, but perhaps a signal of something deeper, a rhythm that transcends time. As the discovery phase closes, one haunting thought remains. Humanity has only just begun to hear the music of the universe. What has been uncovered so far may be but the first bars of a symphony stretching into eternity. The universe has always carried an aura of silence. To the naked eye, the night sky appears serene, points of light suspended in stillness, as if the cosmos itself were frozen. But science, peeling back the veil, has revealed something that shattered this illusion beneath the quiet. The universe trembles with rhythm. The first shock came not from the stars above, but from the relic glow of the universe's birth. The cosmic microwave background, mapped in exquisite detail by satellites like COBE, WMAP, and Planck, revealed a pattern of tiny fluctuations, mere millionths of a degree in temperature. At first glance they looked like noise, random, static, from an old television screen. But hidden in that static were faint, regular ripples. These ripples were baryon-acoustic oscillations, the fossilized sound waves of the infant cosmos. Over 13 billion years ago, the early universe was a seething plasma of photons and matter. Pressure waves rippled through it, expanding outward like concentric circles on a pond. When the universe cooled enough for atoms to form, those waves froze into place. Their imprints remain today, written into the distribution of galaxies. The shock was profound. The universe, thought to be governed by gravity alone, had instead been sculpted by ancient sound. The very spacing of galaxies, the vast filaments of the cosmic web, the arrangement of clusters across hundreds of millions of light years, all bore the signature of an invisible rhythm. It meant that the cosmos was not only expanding, but had been ringing like a drum in its infancy. And those vibrations had left scars across eternity. Equally startling was the precision of pulsars. When Jocelyn Bell Burnell's discovery was announced, scientists were stunned not only by the existence of these rotating neutron stars, but by their unyielding regularity. Some pulsars spin hundreds of times per second, each rotation marking a beat so precise that it rivals the best clocks humanity can build. Unlike human inventions, pulsars never tire, never drift. Their timing is so exact that astrophysicists began to use them as a galactic metronome, a standard of time written into nature itself. Here was another paradox. The death of massive stars collapsed into remnants barely 20 kilometers across. had created the universe's most faithful timekeepers. From chaos, order emerged. From destruction, rhythm was born. That such precision could arise from violence defied expectation. Then came a revelation that shook not just astronomy, but physics itself. In 2015, the Laser Interferometer Gravitational Wave Observatory, LIGO, recorded the faintest tremor imaginable, spacetime itself, vibrating as two black holes merged over 1 billion light-years away. Einstein had predicted such waves a century earlier, but even he doubted they would ever be detected. Yet here it was, the universe ringing in a new key. The shock lay not only in the detection, but in its implication. Space and time, once thought to be unyielding, could ripple like water. The fabric of reality was not static, but dynamic, alive. With gravitational waves, the cosmos revealed itself not only as a stage, but as a player, capable of trembling, singing, pulsing with events of unimaginable violence. But with each revelation, contradictions sharpened. The baryon acoustic oscillations showed galaxies arranged in cosmic rhythms, yet no one could explain why those patterns aligned so precisely with theoretical predictions. Were we simply fortunate? Or was there a hidden necessity in the laws of physics, compelling matter to fall into rhythm? Pulsars added further tension. While most are astonishingly precise, some exhibit sudden glitches where their timing abruptly shifts. These glitches are not fully understood. They suggest complex interiors, superfluid states of matter, but the details remain elusive. If pulsars are clocks, they are not unerring. They are clocks that sometimes lurch, as if the universe itself were hiccuping. And then there are the gravitational waves. Each detection confirmed Einstein's equations, yet also deepened unease. If space-time ripples, then what sustains its rhythm? Why do waves from black holes, billions of light-years away, still reach us, still vibrate with clarity after crossing? The immensity of the cosmos, what invisible order preserves their song? The shocks compounded with the discovery of the universe's accelerating expansion in 1998, Type Ia supernova, used as cosmic candles, revealed that galaxies were not merely receding but doing so faster and faster. The universe's rhythm was changing tempo. Something later called dark energy was pushing space apart with mysterious urgency. The cosmos, it seemed, had a pulse that was quickening. This acceleration introduced an unsettling possibility. If expansion continues, the ancient pulse encoded in galaxies will stretch into silence. The echoes of primordial sound, once preserved in cosmic structure, may be erased by distance. The cosmic rhythm might fade, leaving only stillness. What science uncovered in these decades was paradox upon paradox. A universe once thought silent revealed itself as musical, vibrating with primordial sound and stellar metronomes, yet its very rhythms carried contradictions. Pulsars kept perfect time until they didn't. Acoustic oscillations arranged galaxies, but by rules not fully grasped. Gravitational waves rippled through space-time, but why they persist with such clarity remains a mystery, and dark. Energy suggested the tempo of the cosmos itself could shift without warning. To philosophers and physicists alike, the shock was existential. If the universe has a rhythm, then reality itself may be structured not like a machine, but like a symphony. Yet no symphony plays forever. What happens when the conductor is unknown, when the instruments falter, when the rhythm begins to unravel? The discovery of rhythm in the cosmos was not comforting. It was unsettling, for it revealed a universe both ordered and unstable, precise and fragile, resonant yet unpredictable. It showed that what guides galaxies may not be permanence, but a delicate balance, a fleeting pulse that could one day fall silent. And so, as the shock of these discoveries settled, a deeper mystery emerged. The question was no longer whether the universe had rhythm, but why. The shock of discovery left scientists with awe, but also with unease. A universe with rhythm demanded deeper listening. If the cosmos carried a pulse, where exactly did it come from? Was it a remnant of the beginning, or a rhythm that still actively guides its growth? To answer, science turned to its most powerful tools: telescopes, satellites, particle detectors, and simulations, to peel back the layers of silence and search for patterns hidden beneath. The first place to look was the cosmic microwave background. This faint afterglow of the Big Bang, stretched to microwave wavelengths by billions of years of expansion, became the Rosetta Stone of cosmic rhythm. In the 1990s, NASA's COBE satellite mapped its faint variations, revealing the seeds of structure. Later, the WMAP mission sharpened the picture, and finally, the Planck satellite offered exquisite detail. The maps revealed not random blotches, but organized ripples, sound waves from the universe's first 380,000 years. These oscillations, frozen into the microwave sky, were the earliest record of the cosmic pulse. By analyzing them, scientists could measure the geometry of the universe, the amount of dark matter, the density of baryons. The pulse was not metaphorical. It was written into the very statistics of the cosmos. But the CMB was only the first layer. If those primordial sound waves shaped matter, then their fossilized echoes should still guide the universe today. That prediction led to vast galaxy surveys. The Sloan Digital Sky Survey, SDSS, stretching across decades, mapped millions of galaxies. Out of apparent randomness emerged subtle order. Galaxies are slightly more likely to be separated by about 500 million light-years than by other distances. This preferred scale matched the size of those frozen sound waves. Baryon acoustic oscillations now revealed not only in ancient radiation, but in the modern cosmos itself. Here was the deeper proof. The pulse of the universe was not confined to its beginning. It still shaped the cosmic web today. Galaxies were strung like pearls along invisible filaments, tracing the architecture of primordial sound. The cosmos had remembered its first vibrations and used them as a guide to grow. The investigation deepened further with the discovery of pulsars as cosmic clocks. These neutron stars, spinning remnants of collapsed suns, offered not only precision but also a tool, if monitored together. Across the sky, their timing could reveal the faintest tremors of spacetime. This gave birth to pulsar timing arrays. Collaborations like Une-Ionograv, EPTA, and PPTA, which monitored dozens of pulsars for decades. In 2023, a tentative breakthrough arrived, evidence of a low-frequency gravitational wave background. Unlike LIGO's detections of short, violent collisions, this signal would be the deep bass of the universe, waves produced by supermassive black hole binaries spiraling together over millions of years. If confirmed, it would mean that the universe not only pulses with ancient sound and stellar clocks, but also with a hum produced by the dance of galaxies themselves. To simulate such a universe required immense computational power. Projects like the Millennium Simulation and Illustris created virtual universes, filled with dark matter and gas, evolving under gravity. When seeded with primordial oscillations, these simulations produced filaments, clusters, and voids nearly identical to what telescopes see. Without the rhythm, structure collapsed into chaos. With it, the web unfolded with elegance. The models showed that the pulse was not decorative. It was structural, essential. Without rhythm, there would be no galaxies, no stars, no life. Yet, even in this deep investigation, anomalies whispered. The CMB cold spot, a vast region cooler than its surroundings, defied expectations. Was it a statistical fluke, or an echo of something deeper? Perhaps the imprint of another universe brushing against ours. Pulsar glitches, sudden irregularities in otherwise perfect rhythms, hinted at exotic states of matter, and quark condensates hidden inside neutron stars. Even the large-scale distribution of galaxies revealed discrepancies at small scales, tensions that suggested either missing physics or an incomplete picture of the pulse's origin. Science probed with increasing sensitivity. Radio telescopes traced the faint 21-centimeter signal of neutral hydrogen, hoping to map the universe during its dark ages, before the first stars lit. These signals would reveal how the primordial rhythm carried through the silence, shaping the dawn of galaxies. Even human technology, when measured against these cosmic clocks, seemed fragile. Pulsars timed across decades were so precise that they offered navigation more accurate than GPS, a potential galactic map for future explorers. The deeper science looked, the clearer it became. Rhythm was not an anomaly but a framework, a hidden lattice upon which reality rested. Yet the question grew heavier. Why rhythm? Why sound at the beginning? Why pulses in dead stars, ripples in spacetime, and preferred scales in galaxies? Why did patterns repeat across scales so vast they seemed disconnected? The deeper investigation uncovered coherence where none was expected, from the first seconds of the universe to the deaths of stars, from the microwaves filling space to the gentle tug of galaxies. Rhythm appeared again and again. It was not confined to a single phenomenon. It was a unifying thread, subtle but persistent, and in that recognition lay both wonder and fear. For if the universe has rhythm, then perhaps it has memory. Perhaps it is not random but guided, shaped by pulses older than stars. Or perhaps rhythm is fragile, a fleeting resonance that could someday be disrupted. The investigation answered many questions, but it raised more profound ones still. The pulse of the cosmos was real, but was it a remnant of the past or a guide toward the future? The deeper scientists listened to the universe, the more uncanny its rhythm became. What began as faint echoes in ancient light and stellar clocks evolved into something stranger, a cosmic beat that did not simply exist, but shifted, accelerated, and contradicted expectations. The universe's pulse was not a steady metronome. It was a rhythm of tension, carrying mysteries that grew darker the more it was studied. The first tremor of escalation came in 1998. Two independent teams, studying distant type Ia supernova, expected to measure the slowing expansion of the universe. Gravity, after all, should tug on galaxies, gradually pulling them back. Instead, the data revealed the opposite. The expansion was accelerating. A mysterious repulsive force, later called dark energy, was driving galaxies apart faster and faster. This revelation shattered simplicity. The primordial pulse had guided galaxies into filaments, arranging matter with elegance. But now, expansion itself was quickening, as though the rhythm had changed tempo. If dark energy continued, the universe's pulse might race toward a fate where galaxies drift beyond sight, stars fade, and even atoms unravel. The cosmic heartbeat no longer promised stability. It hinted at endings as well. Complications multiplied. The cosmic microwave background, once thought a perfect canvas, revealed subtle irregularities. The CMB cold spot remained unexplained, while alignments of large-scale fluctuations, nicknamed the axis of evil, suggested a preferred direction in the sky. If true, the cosmic pulse was not uniform. It had asymmetries, like a drum stretched unevenly. Some physicists dared to ask, were these the scars of another universe brushing ours, or relics of forces from before the Big Bang? Even pulsars, once the steadiest clocks in the galaxy, revealed unsettling surprises. Some entered sudden glitches, abrupt shifts in spin frequency, as if their rhythms stuttered. Inside these collapsed stars, matter may exist in states unknown to laboratories. Neutron superfluids, quark seas, or exotic phases that defied ordinary physics. The glitches hinted that the pulse of the cosmos was not perfectly stable, but punctuated by disruptions, mysteries wrapped in nuclear densities. Then came the deepest vibration yet. In 2023, the UNANOGRAV collaboration announced hints of a gravitational wave background, a universal hum produced by countless pairs of supermassive black holes orbiting across billions of years. Unlike LIGO's sharp chirps from stellar collisions, this was a continuous rumble, a bassline woven into spacetime itself. If confirmed, it would mean that the cosmos did not simply echo its beginning, it still sings, a chorus of galaxies contributing to a universal hymn. Yet even here, unease grew. The detected signal's strength and spectrum did not match all models. Some speculated it came not only from black holes, but from more exotic origins, relic gravitational waves from the Big Bang itself, or even from phase transitions in the early universe when fundamental forces split apart. If so, the pulse was not merely astrophysical. It was woven into the very act of creation. The mystery deepened with tensions in the Hubble, constant the rate of cosmic expansion. Measurements from the local universe, using Kyphids and supernova, conflicted with values inferred from the CMB. The disagreement was small in number, but vast in implication. Either new physics shaped the early universe, or something about cosmic rhythm was misunderstood. Some proposed dark radiation, new neutrino species, or exotic interactions in the primordial plasma. Others whispered that the tension might be the first crack in our cosmological model, a sign that the pulse conceals a deeper layer still unseen. Even dark matter, the silent partner of cosmic rhythm, entered the puzzle. Simulations of galaxy distributions predicted patterns at small scales that reality refused to show. Dwarf galaxies behaved oddly. Dark matter halos seemed less concentrated than expected. Some proposed new interactions within the dark sector, as if dark matter itself carried hidden pulses, rhythms of a shadow world that shaped the visible one. The escalation of evidence began to feel overwhelming. The universe was not only pulsing, it was full of discordant notes. Acceleration contradicted gravity's pull. Pulsar glitches disrupted stability. Anomalies in the microwave background challenged uniformity. Gravitational hums suggested hidden choirs in spacetime, and discrepancies in expansion rates hinted at missing pages in the cosmic score. Philosophically, the unease deepened as well. If the universe's pulse could accelerate, change, or fracture, what did that mean for the future? A pulse implies life, rhythm, continuity. But what if the beat faltered? What if dark energy grew stronger, driving a big rip where galaxies, stars, planets, and finally atoms are torn apart by expansion. The cosmic metronome would not guide, it would destroy. Or perhaps rhythm itself is cyclical. Some cosmologists speculate that the universe may contract one day, the pulse slowing, then reversing into a big crunch, or bouncing into another expansion. In such models, the cosmos is eternal heartbeat, expanding and contracting eon after eon. But even here, uncertainty reigns. Would memory carry across cycles? Or would each pulse erase the last? A rhythm without memory, endlessly repeating yet never continuous. The mystery of the cosmic pulse no longer lay in its existence, but in its contradictions. It was everywhere, but not fully understood. It shaped galaxies, yet defied explanation. It carried elegance, yet hinted at danger. The pulse had grown from a discovery into a dilemma, a paradox, guiding science deeper into the unknown. The escalation leaves one haunting truth. The cosmos is not silent. It vibrates with rhythm, sometimes stable, sometimes chaotic. Its pulse carries both creation and destruction, order and uncertainty. And as science digs deeper, it becomes clear the beat of the universe is not background noise. It is the script of reality itself, written in vibrations that may one day reveal where everything began and where it is destined to end. As the evidence grew stranger, the pulse of the cosmos demanded more than observation. It called for interpretation. Scientists and philosophers alike began to ask, what is rhythm at the scale of the universe? Is it fossil memory lingering from a fiery birth? Or is it a deeper necessity, a principle etched into the fabric of reality itself? The most grounded explanation lies in the physics of the early universe. In its first 380,000 years, matter and light were locked together in a hot plasma. Sound waves rippled through that dense ocean, oscillations of pressure and gravity. When the universe cooled and atoms formed, light decoupled from matter, freezing those ripples into space itself. These are the baryon acoustic oscillations, echoes of ancient sound imprinted in the cosmic distribution of galaxies. To many, this is the simplest interpretation of the cosmic pulse. The rhythm of creation preserved as structure. The universe itself remembers its first breath. Yet this is only one layer. Some physicists see pulsars as manifestations of a deeper universal rhythm. These collapsed stars, born from supernova, spin with such precision that they keep time better than atomic clocks. Their beams sweep the cosmos like metronomes, anchoring time across billions of years. To rely on them for navigation or calibration is not just technological convenience, it is to entrust human activity to the heartbeat of dead stars. Pulsars, in this sense, are like living fossils of cosmic rhythm, each one carrying the memory of stellar death and transformation. More speculative are theories of a gravitational symphony. The 2023 hints from Unayanograph suggested that a background of low-frequency gravitational waves hums across the universe. If confirmed, it would mean the cosmos has a baseline, produced not by stars or galaxies alone, but by the mergers of supermassive black holes, or perhaps by primordial events during inflation. Some even suggest that what we hear in gravitational waves today might be the universe's first vibration, its earliest shudder stretched across eons. Other frameworks step further into speculation. In the holographic principle, reality itself is seen as a projection from a deeper, two-dimensional boundary. If so, the rhythms we detect, BAOs, pulsar ticks, Gravitational wave backgrounds may not be fundamental at all. They may be shadows of patterns on that boundary, encoded in ways our three-dimensional intuition cannot fully grasp. The cosmic pulse would then be less like sound, more like holographic interference, a deeper geometry masquerading as rhythm. Quantum field theory offers yet another perspective. In this view, the universe is not empty but filled with fields, constantly oscillating with fluctuations. The vacuum itself trembles with energy, even in its lowest state. The pulse of the cosmos may thus be nothing more and nothing less than the beat of quantum fields, their excitations scaled up to cosmic proportions. If so, the universe has always pulsed and always will, not because of history but because of nature's most basic rule. Fields cannot remain still. Some cosmologists speculate about false vacuum decay. According to this idea, the universe may be in a metastable state, a kind of false ground. If true, then the pulse we detect is not only rhythm but warning. Vibrations of a reality that may one day shift to a lower energy state. Should that occur, the universe's laws could rewrite themselves in an instant. Particles, forces, and structures would vanish. The pulse would stop, only to begin again in a form utterly alien. In this scenario, rhythm is fragile, the metronome of the cosmos ticking toward a sudden silence. Even more audacious are ideas drawn from multiverse speculation. If our universe is one among many, each may possess its own frequency, its own rhythm of expansion, oscillation, and decay. Our cosmic pulse would be one note in an infinite symphony, a single vibration in an endless orchestra of realities. The anomalies in the CMB cold spots, alignments, are sometimes interpreted as possible evidence of collisions with other universes, as if rhythms overlapped, briefly touching across boundaries of existence. Philosophers have long been drawn to the metaphor of rhythm. In Nietzsche's thought, the idea of eternal recurrence imagined a universe that cycles infinitely, each event repeating endlessly. Some physicists see echoes of this in modern cosmology, universes expanding and contracting, each beat birthing the next. In such visions, the cosmic pulse is eternal, a spiral of rhythm without beginning or end. There are also models of cosmic heartbeat cycles, universes that breathe. In these scenarios, expansion slows, reverses, and collapses into a big crunch, only to bounce into a new expansion. Matter and energy are recycled, and the pulse is the marker of each eon. Recent proposals of loop quantum cosmology suggest that singularities may not exist. Instead, contraction always leads to a bounce. If true, then the pulse of the cosmos is not just memory, it is destiny, guiding reality into endless renewal. More radical still are speculations that the cosmic pulse is evidence that the universe itself is alive in some metaphorical sense. Biologists speak of rhythm as the essence of life, the heartbeat, the breath, the circadian cycle. To find rhythm at cosmic scales tempts reflection. Is the universe not a machine but an organism? Its expansion and oscillations the signs of life on a scale beyond comprehension. Though not scientific in a strict sense, such metaphor echoes the awe scientists themselves confess when contemplating cosmic harmony. Even in these speculations, caution remains. The pulse may be no more than mathematics, equations describing waves, oscillations, vibrations, nothing mystical beyond their patterns, yet to reduce them to symbols is to miss their resonance. The universe's pulse is not simply measurement. It is reality sculpted by rhythm, galaxies arranged by echoes, time kept by neutron stars, spacetime itself trembling with waves. The theories diverge from sound waves in the primordial plasma, two holographic projections, two cycles of eternal recurrence. Some are grounded in data, others in imagination. Yet all circle the same haunting truth. The cosmos does not drift randomly. It carries rhythm, written in its birth, sustained in its evolution. Perhaps guiding its fate in the end, the speculations are less about answers than about perspective. To interpret the cosmic pulse is to ask whether the universe is memory, destiny, or something beyond both. Perhaps it is music, not metaphorically, but literally. Vibrations encoded in space and time, a score too vast for human ears, but perceptible in equations, instruments, and stars. Theories may shift, evolve, collapse, but the rhythm remains. The universe pulses, and in its beat, humanity searches not only for physics, but for meaning. To follow the pulse of the cosmos is to listen with instruments finer than any ear, to see with eyes sharper than light itself. Humanity has built an orchestra of machines, telescopes, detectors, satellites, each designed to capture whispers from the universe's rhythm. Together, they form a global, even interstellar, effort to measure the beat that guides galaxies and perhaps reveals destiny. The first instruments are the pulsar timing arrays. Spread across continents, these are networks of radio telescopes, the North American Unanograph, the European Pulsar Timing Array, the Indian PT, and soon the Square Kilometre Array, SCAR, rising from South Africa and Australia. Their purpose is exquisite in its simplicity, to listen to each pulsar spins with a regularity rivaling atomic clocks, sending radio flashes that sweep past Earth like the beams of cosmic lighthouses. By timing their arrival with extreme precision, astronomers can detect distortions in spacetime itself. If a gravitational wave passes between Earth and the pulsar, the beat shifts just slightly. Over years of observation, arrays of pulsars become a galactic detector, sensitive to waves not of kilohertz but of nanohertz, the slowest, deepest baselines in the universe. In 2023, hints emerged. The pulsars were drifting in synchrony, suggesting the presence of a universal hum. Perhaps the pulse is not metaphor, but a literal background vibration, stitched into spacetime at higher frequencies. Gravitational wave observatories like LIGO, Virgo, and Cagra stretch laser beams across kilometers. These instruments already confirmed Einstein's vision, detecting mergers of stellar black holes and neutron stars. But their true significance may lie beyond those cataclysms. Future upgrades and the planned LISA mission, a constellation of spacecraft orbiting the Sun, will listen for gravitational waves with periods of hours to months. If pulsar timing arrays are attuned to the bass and LIGO to the soprano of black hole collisions, LISA will hear the baritone, supermassive black holes spiraling together across billions of light years. The universe's full symphony will require. Every register and every detector adds another instrument to the score. Yet the pulse is not only heard in gravity, it is seen in light. The cosmic microwave background, CMB, remains our most faithful record of the primordial oscillations. Satellites like COBE, WMAP, and Planck mapped it with increasing precision, showing the faint ripples imprinted at the dawn of time. But the story is not finished. Next-generation missions, such as Light Bayard and the ground-based CMBs, will probe the polarization of the CMB, searching for the telltale twists that inflationary gravitational waves would leave behind. If detected, they would confirm that the universe once vibrated with unimaginable violence, stretching quantum fluctuations into cosmic architecture. These instruments may reveal not only the origin of the pulse, but the very physics of creation itself. On larger scales, galaxy surveys act as cartographers of rhythm. Projects like the Sloan Digital Sky Survey, SDSS, first uncovered the subtle spacing of galaxies, baryon acoustic oscillations, fossilized in cosmic structure. Today, more ambitious efforts like DESI, Dark Energy Spectroscopic Instrument, Euclid, and the Vera Rubin Observatory are mapping millions, even billions of galaxies. Their goal is not merely cataloging. By tracing the cosmic web across time, they measure the scale of oscillations and the expansion of the universe itself. Every filament, every void, is a note in the frozen symphony of the cosmos. To map them is to reconstruct the score, to hear the universe's rhythm across billions of years. The James Webb Space Telescope, JWST, though famed for its portraits of galaxies, contributes as well. By observing the earliest galaxies, JWST offers a test. Do young galaxies align with the patterns predicted by ancient oscillations? Already, Webb has revealed galaxies surprisingly mature at times when the universe was only a few 100 million years old. Their arrangement, structure, and light may hold further clues about how primordial pulses shaped cosmic dawn beneath the Earth. In mines and caverns shielded from radiation, another search unfolds. Quantum experiments probe the vacuum itself. Detectors like Xenont, LuxZeppelin, and Pandex, built to hunt dark matter, are in some sense listening for a different kind of rhythm, fluctuations of unseen fields. If dark matter is linked to primordial oscillations, its discovery may unify to mysteries, the invisible scaffold and the universe's beat. Even if these detectors remain silent, they constrain possibilities, refining the models that attempt to explain the pulse. High-energy astrophysics also plays its part. Space missions like Athena, ESA, and concepts like Lynx NASA are designed to probe X-rays from black holes and galaxies, tracing how cosmic structures evolve. These instruments do not directly measure oscillations, but they test their consequences. The formation of filaments, the feeding of supermassive black holes, the growth of galaxies. If the rhythm shaped matter, these missions will reveal how. There are still more speculative frontiers. 21-centimeter cosmology, the study of neutral hydrogen's faint emission, promises to map the cosmic dark ages, the era before stars. Instruments like LAFA, Hera, and eventually the SKR, attempting to capture this faint glow. If successful, they will expose the scaffolding of dark matter and oscillations before galaxies ignited. This would be like listening not to the echoes of a song, but to its rehearsal, the universe humming before the music began. Even quantum laboratories may contribute. Experiments testing vacuum fluctuations, an entanglement probe whether the cosmic rhythm is rooted in quantum fields. Some physicists wonder if the pulse is not merely a feature of large-scale structure, but an inevitable outcome of quantum uncertainty. Itself to confirm this would be to unify the smallest with the largest, showing that rhythm is not an accident but the essence of reality. The unity of these efforts is striking. Across continents and disciplines, science strains to detect and decode the cosmic pulse. Radio telescopes time pulsars, spacecraft listen for gravitational waves, satellites measure ancient light, ground surveys map galaxies, cavern detectors search for invisible matter. It is a pursuit not of one phenomenon, but of harmony itself, the recognition that rhythm pervades all scales, from quantum fields to galactic webs. Each tool sharpens the picture. Each observation narrows possibilities. But together they suggest something more profound. Humanity is building not just instruments, but a kind of cosmic ear. The Earth itself has become a detector, its surface bristling with telescopes, its orbit filled with satellites, its depths lined with sensors. Our planet listens, tirelessly, to a universe that hums across silence. And yet, humility remains. These tools are vast, precise, costly, and fragile. They are tuned to hear faint whispers across billions of years. But even with them, the full score of the cosmos remains incomplete. The pulse may hide notes, too faint, too deep, too strange for any machine. It may lie forever beyond detection. Still, humanity persists. To measure the pulse is to reach toward the heart of creation. Whether the effort succeeds or fails, the instruments are more than machines. They are extensions of human curiosity, embodiments of the desire to know if the universe carries rhythm, memory, and destiny within its silence. Science listens. The cosmos beats. Between them lies the possibility of revelation. The universe appears to be silent, yet everywhere within that silence, rhythm waits. A star flickers, a pulsar spins, a galaxy cluster breathes, and the faint hum of ancient sound waves lingers in the glow of the cosmic microwave background. These are not random echoes. They are fragments of a deeper order, the pulse that guides the cosmos. To speak of the pulse is to walk the thin boundary between physics and philosophy. On one side lies measurement, equations, telescopes, data. On the other lies reflection, the awareness that rhythm is not only a physical property, but also a metaphor, a way of seeing ourselves within the universe's story. If the cosmos beats with a hidden heart, then existence is not chaos but music. Every living being knows rhythm intimately. The heartbeat steady yet fragile, the inhale and exhale of lungs, the circadian cycle binding life to the turning of earth. Humanity arose within rhythms long before it understood them. The rising and setting of the sun gave order to survival. The phases of the moon governed agriculture, ritual, and myth. Even before science, rhythm was the language through which the universe spoke to its children. Now, with telescopes peering billions of years into the past, science recognizes that rhythm belongs not only to life, but to matter itself, the same. Oscillations that guided the arrangement of galaxies echo faintly in the beating of human hearts. To live is to embody a miniature version of the cosmic pulse. Every life is a temporary resonance in a song that began before time and will continue beyond memory. Yet there is fragility in this discovery, for if the cosmos has a pulse, could it one day stop? Stars exhaust their fuel, pulsars slow, even black holes evaporate across unimaginable spans of time. The rhythm we hear may not be eternal but transient, a verse in a greater composition whose next movement we cannot predict. The possibility unsettles. If existence is music, it is also fleeting. Philosophers have long wondered whether the universe is alive in some sense. To call its rhythm a heartbeat is poetic, but also provocative. Is the cosmos breathing, expanding, and contracting like lungs? Is dark energy a quickening of pace, or the faint sign of exhaustion? Or is rhythm simply the inevitable consequence of physics, not vitality, but necessity? The distinction is subtle yet profound. If the universe is alive, then perhaps it has intention. If it is mechanical, then rhythm is no more than accident. The pulse invites reflection on memory. The baryon acoustic oscillations, those frozen sound waves from the first few 100,000 years, are not sounds we can hear, yet they are the earliest memory of matter. They are the universe recalling its own childhood. The faint flicker of pulsars, stable over millions of years, is a different kind of memory, time recorded in the turning of collapsed stars, and gravitational waves rippling across billions of light years. Our memory carried by spacetime itself. The pulse is not simply present, it is remembrance. In this sense, the universe does not forget. It remembers its beginning in vibrations etched across the cosmic web. It remembers collisions of black holes in tremors that reach detectors on Earth. It remembers the deaths of stars in pulsars that beat with eternal regularity. To study the pulse is to study memory itself, a memory older than galaxies, older than light. But the memory is incomplete. In the cold silence between pulses, the universe conceals what it does not reveal. There is no guarantee that humanity can ever reconstruct the full rhythm. Perhaps what is known now is only an overture. Perhaps the true symphony lies in registers. Science cannot yet measure. Some pulses may be too faint, too vast, too alien. The universe may keep secrets even as it sings. This leads to a deeper question. If the cosmos has rhythm, does it have meaning? Music is never mere vibration. It is vibration ordered into significance. If the universe's pulse is mere coincidence, then its order is illusion. If it is necessary, then meaning lies within the laws of physics themselves. But if it is chosen, if reality resonates because it must, not only because it can, then the pulse is more than structure. It is intention written into being. Einstein once said that the most incomprehensible thing about the universe is that it is comprehensible. The pulse embodies this paradox. Out of chaos emerges order, precise enough to measure, steady enough to predict, beautiful enough to inspire. The fact that human minds, products of stardust and chemistry, can recognize, calculate, and even anticipate the rhythm of galaxies is itself astonishing. To listen to the universe and hear music is not inevitable. It is privilege. Yet the recognition of rhythm also changes how existence is seen. If reality is music, then every being is a note, every action a chord, every life a phrase. The death of a star is not silence, but transition, its elements spreading into space to compose new melodies. The merging of black holes is not destruction, but crescendo, a cosmic drumbeat reverberating across spacetime. Even entropy, the gradual fading of order, becomes less a failure and more a key change, a modulation to a different, quieter theme. There is humility in this. Humanity's rhythms are brief compared to cosmic ones. A heartbeat lasts seconds, a life decades, a civilization perhaps millennia. Pulsars spin for millions of years. Gravitational waves travel for billions. The universe may pulse for trillions. More, to place human existence within this scale is to feel small, but also connected. Fragility becomes part of harmony. What then of destiny? If the pulse is memory, does it also serve as prophecy? Some theories suggest the universe may oscillate endlessly, expanding and contracting like a lung. Others hint at a false vacuum, where the pulse could end abruptly, replaced by silence and a new song. Perhaps the pulse is eternal. Perhaps it is ephemeral. Science cannot yet say. The uncertainty is not failure, but invitation, to wonder, to imagine. to prepare for answers not yet conceived. In the end, the pulse that guides the cosmos is not only out there, it is here. It is within the beating of hearts, the breathing of lungs, the ticking of clocks, the turning of earth. It is in the cycles of thought, the repetitions of history, the rhythms of art and music. Humanity resonates with the universe because it is part of the universe. To hear the pulse is to hear kinship, and so the story closes where it began, with silence and with rhythm hidden inside it. The night sky still appears quiet, but the galaxies move to an ancient beat. Pulsars tick across the abyss like metronomes of eternity. Gravitational waves hum in the background, slow and deep. The cosmic microwave background glows with fossilized chords from the dawn. Perhaps the universe will one day fall quiet, its rhythm stilled. Or perhaps it will continue to pulse forever, each cycle giving rise to new forms, new beings, new ways of listening. Either way, the lesson is the same. The cosmos is not a machine drifting into darkness, but a song, vast, fragile, unfinished. The final haunting question lingers: is the pulse of the cosmos merely an echo, fading from its beginning, or is it the steady beat of eternity itself, guiding reality toward a destiny beyond imagination? The silence waits, the rhythm endures, the universe continues to breathe.